This is the second half of the Algebra 2 6.6 notes, starting with example 4. So in example 4, we are continuing on our work with solving logarithms. And as you can see here, this one has two logs. There's log of 2x and log of x minus 5. So back in 6.5, we had learned to condense logarithms using three properties. This is where we need it. We cannot solve this log until it's combined into one. So we had learned, you don't have to write this down, I'm just referencing this from 6.5. We had learned the product property, which basically said if you have log of a base, then, like base m, and its two things being multiplied inside the log, then you can break it up as log base m of x plus log base m of y. That's what the product property let us do. And we learned to take and expand a log into two things and take two things and condense them back into one. So these are two logs we need to condense into one. So using the reverse of the product property, we know that it's log of 2x times x minus 5. So they are multiplying together. So I'm going to go ahead and multiply 2x times x is 2x squared. 2x times negative 5 is negative 10x. Okay, so now we have this into a single log. So what we need to do to solve a log is rewrite it as an exponential. So since this one has no base written, we know that it's a common log, meaning it has a base of 10. So also going back to the very beginning of this chapter, once again, you don't have to write this, it's just I'm going to show you. We learned that when we have a log, we can rewrite it as this exponential, and they can go back and forth like that. So if we start with the base, it's the base of 10, and then it's to the power of 2, because remember how you do b to the x equals y? So 10 to the power of 2 equals what was in the log. So equals 2x squared minus 10x. All right, so 10 squared is 100. Now, this is a quadratic now. You can see it's got x squared as its highest power. So to solve a quadratic, the first thing I need to do is get it equal to 0. So I'm going to move that 100 over to the other side. So all I did was subtract 100 on both sides. Now, I also see that I have 2, 10, and 100. Everything there is divisible by 2. So I'm going to divide that by 2. Okay, so what that leaves us with, 0 divided by 2 is still 0. And when you divide the right-hand side by 2, you get x squared minus 5x minus 50. Okay, so now you have a quadratic that is equal to 0. Back in chapter 2, we learned 5 ways to solve quadratics, but the 2 ways we use the most are factoring and quadratic formula. This is a trinomial, so it's going to factor really nicely. I can just kind of tell by looking. So remember the rules on factoring a trinomial? It has to multiply to AC and it has to add to B. So that means it has to multiply to A is 1 right here, and then times C is negative 50. So it's got to multiply to negative 50, and it has to add to negative 5. Okay, so the numbers that do that, you can make a list if you need to, but I know that the numbers that do that are negative 10 and positive 5. So they make negative 50 and they add to negative 5. Now, because this is a trinomial that just starts with x squared, there's no coefficient or number in front of x squared. I know it's what we call the easier kind of factoring. And so what that means is I can just go ahead and do x minus 10 times x plus 5. Now I set each of those equal to 0. And my answers are x equals 10 and x equals 5. I'm sorry, negative 5. We got to subtract that 5 over. Okay, now, always be careful on logs. You need to check on the logs to see if they work. For the record, if you have log of 0 or log of a negative number, neither of those exist. All right, they are going to come up in a calculator with an error. They are undefined, like it's not possible. And so you cannot do those. So when you plug back in 10, for example, log of 2 times 10 is 20. That's fine because you can take log of a positive number. And plug in 10 for the second one, 10 minus 5 is 5. That's also fine. And if you plug that in a calculator, it totally will equal 2 and check out. All right, but if you plug in negative 5, 2 times negative 5 is negative 10. Right there, I know negative 5 is not going to work because I cannot take log of a negative number. So it's an extraneous solution and I just don't use it, and x equals 10 is my only solution. Okay, let's go ahead and look at example 5. So on example 5, we want to solve an exponential. So we're going to use a log to solve an exponential. Now it has an inequality. That's not a big deal. I'll just show you how to work with it. So this has a base of 3. So what I want to do is I want to take log base 3 to both sides. Now I can't just do it to one side. I have to do it to both. So the left side I'm putting inside log base 3 and the right side inside a log base 3. Okay, so we had learned previously that when you have log base b of b to the x, it will end up just leaving x. So when the base of the log and the base of what is inside the log are the same, they will just leave the exponent. So this log base 3 of 3 will cancel out and just leave x. And then this log base 3 of 20, I'm just going to type in my calculator and I get 2.727. And that's my answer. Okay, before we go any farther, let's go ahead real quick and just take a look on the self-assessment. Let's practice those two real quick. So on number 2C, they are two separate logs. So first we want to combine them. So we're going to combine them using our product property, which we know since the logs have the same base and they're being added, we can put them in one log and multiply them. So that turns into log of 5x squared minus 5x. All right, equals 2. So now to solve a log, you write it as a exponential equation. So this is log base 10. So remember, you do 10, and then the exponent is what was over here on the other side of the equals. So 10 squared equals, and what it equals is what was inside the log. So 5x squared minus 5x. All right, this is 100. 10 squared is 100. And then to solve a quadratic, first you're going to want to get everything to one side. So I'm going to subtract the 100. So I get 0 equals 5x squared minus 5x minus 100. Now your life is so much easier when you can divide by something to make your numbers smaller. So everything on the right side, will divide by 5. Let me fix that real quick. All right, and so you'll have x squared minus x minus 100 divided by 5 is 20. So once again, quadratic formula or factoring are what we're going to do. This looks like it'll probably factor pretty nicely. So it's got to multiply to AC. A times C is negative 20. It's got to add to B. B is negative 1. All right, so 5 and 4 are going to be our numbers, but we've got to figure out our signs. I think it's going to be negative 5 and positive 4. All right, so that will give me x minus 5, x plus 4. So when I set them equal to 0, I will add the 5 over and get 5, and I'll subtract the 4 over and get negative 4. Now you always have to go back in and check. When I plug in 5, I get log of 25, that's fine. And 5 minus 1 is 4, that's okay. And if you do it in a calculator, that will check out. Now when you plug in negative 4, I get log of negative 20 because 5 times negative 4. Right there, I know negative 4 is not going to work. There are times where a negative will check out, but you always have to plug it back into the log and see what happens. Okay, and now let's look at 3a. Okay, so remember what we had just done is we had done a log on both sides. We chose to do log base 3 because this was a 3. Okay, so this is e to the x. So how we get rid of an e is by using log base e, which remember, log base e is just natural log. So we natural log the left side and we natural log the right side. Okay, when we have the natural log of e to the x, that's like log base e of e to the x. So it cancels out and just leaves x. And then natural log of 2, I can totally just do in my calculator. I don't know it any other way. And it's 0.693. Okay. So here we're going to look at example 6. So when we're trying to do this and it's a log of x, if I'm trying to do it and I attempt to do like log base 10 of x less than or equal to 2 and then rewrite it as a power, the problem is I don't know if my sign is supposed to go this way or this way. So how we're going to tackle these is I know that this is log base 10. And then I also know that, like if I have log base 10, I can do 10 to the power of log base 10, and that will cancel out. I know that will leave x. And so if I do that though, I have to do 10 to the power of 2 on the right-hand side, which I know is 100. I went back to look real quick of when we learned this. This was in 6.3 on the inverse properties, and what we learned is two different things. We learned when you have log base b of b to the x, you just get x. And we also learned when you have b to the log base b of x, you just get x. So this was in 6.3 example 5, if you need to go back and refer to that. Okay, now logs are tricky because what this is saying right here is saying that the solutions are any number less than or equal to 100. And that's somewhat true, but keep in mind, logs cannot be a 0 and you cannot have a log of a negative. So numbers under 100 will work, but not 0 and not negatives. So you've got to go ahead and just pick kind of an end cap on here. And what this is saying is, okay, numbers less than or equal to 100 will work, but they have to be larger than 0. Because remember, you can't do a 0 inside a log, and you can't do a negative number. All right, I'm going to go ahead and jump down here and do 3b. So before I try to get the log and solve it, I have to move that 9. So I'm going to have to subtract the 9 over, and I get 36. All right, so now remember, how we're going to get rid of this log is we know this is a log base 10. So we're going to do 10 to the log base 10x, and then on the other side, I have to do 10 to the 36. I have to use that inverse property on both sides. So I get x, and I get 10 to the 36. Now, I'm not going to write out 10 to the 36 because that's a ton of zeros. That's just kind of crazy. So we're just going to leave it there. But remember, just because it says any number less than 10 to the 36, okay, but not 0 and not negative. So you have to, because it's a log, you have to put this, the x has to be greater than 0, and that's because log of 0 or log of a negative number does not exist. So when you need to watch out for that is when you have an inequality, specifically with a log or a natural log. If it's an inequality of an exponential, you don't have to watch out for that because exponentials will work with any real number. You only have to watch with an inequality and a log or a natural log.